This is the first of a group of lessons on Core 2 trigonometry. We're going to start off looking at trig functions and their graphs. And we'll start with the graph of sine theta. We're going to look at this graph initially just between 0 and 90 degrees. If we use this unit circle, and what we mean by a unit circle is a circle with a radius of 1, and we create this angle here, theta, we can see that sine theta, using our knowledge of trigonometry and SOHCAHTOA, is the opposite side over the hypotenuse, which is y over 1. So in other words, sine theta equals y. It equals the y value here. This is true of any angle here. So if we have sine 20 degrees and putting our lengths of y in here up to a maximum of 1, which we get at 90 degrees, we can see the shape that the graph makes. And we get a shape like that. So as theta increases between 0 and 90, y increases from 0 to 1. Okay, well we've only looked at between 0 and 90, but we're now going to extend our definitions so we can look at any angle theta, whether it's positive or negative. Well, when theta is 30 here, sine theta is 0.5. And we can see here that with this 30-degree angle, in other words, an angle for theta of 150 degrees, we also get a value, a y value of 0.5. So we looked at the first quadrant between 0 and 90, and we can also see that there's an angle in the second quadrant where the y value, the sine value, is the same. We started with 30, and then it was 180 minus 30, wasn't it? 150 degrees, which gave us the same sine value. And this is always true. So for sine 70, it's 180 minus 70, 110 degrees, that gives us the same y value. Notice this symmetry. These trig graphs are all about symmetry, and if you can understand that symmetry of the graphs, you're a long way towards understanding the trigonometry you need for A-level maths. So we can use that symmetry now to draw the sine graph between 90 and 180. For the third and fourth quadrants, we can see that we're going to end up with negative y values, but the same symmetry applies. Study this here and try and understand where these different angles are coming from. 30 degrees here. This is 30 degrees, which makes this 360 minus 30. It's the same length in the negative direction, so the value of sine 330 degrees is minus 0.5. We can extend a similar logic to the angle 210 degrees. The sine of 210 degrees is minus 0.5, and we can see why here, perhaps by comparing it to 150 degrees, which we'd already previously established had a same sine value as 30 degrees. So there we are, those negative values. And this is what we end up with. So between 0 and 360 degrees, y equals sine theta looks like this. When we get beyond 360, we just repeat the process. The sine graph is what we call a periodic graph. It repeats, and it repeats every 360 degrees. So sine 30 has the same value as sine 30 plus 360, in other words, sine 390 degrees. And we can see there that the graph just keeps repeating every 360 degrees. We can define our negative angles by moving in a clockwise direction instead of the anti-clockwise direction which we moved in previously. And we can see there that it continues in a negative direction, again repeating every 360 degrees. You do need to know this graph, you need to be very familiar with it. You'll be using it for a lot of things to do with trigonometry, solving equations, finding different values, different angles with the same y value or sine value throughout AS and A2 maths. So to summarise, sine theta is defined for any angle. So theta is a member of the set of real numbers, if you like. It repeats every 360 degrees. It has a minimum value of -1 and a maximum of 1. This is the graph, and you really do need to memorise it. You can use your calculators to find it in Core 2, but the more familiar you are with it, the easier you're going to find all of the many times when you need to use it. Okay, now have a go at this yourselves. Pause the presentation, have a go. If you're successful, move on. If not, then go back over this. There we are. So there's your graph. It's asking for an angle between 0 and 360 where sine theta is equal to sine 40. Well, the other occasion there is 140, isn't it? So that's the answer to A. For B, 240, well, you can see here where it's equal, and it's 300. C, 50 degrees is there. We're looking at -50 degrees. So -50 degrees is where this length is the same in the negative direction, and that's here, isn't it, at 230 and at 310. And then finally -280. Well, 280 is here, so -280 will be where this distance is repeated in the positive direction here, won't it? So 80 and 100. Okay, now have a go at this. Again, pause the presentation, have a go. If you're successful, then you're ready to move on. So there's the cos graph. Notice it's symmetrical about the y-axis, so it's symmetrical in the y-axis, so cos of any angle is the same as cos of minus the same angle. So in other words, cos 60 has got the same value as cos minus 60.